happens if we have variables on both sides of an equation? Well, we use the addition or subtraction property of equality. In other words, we rearrange it so that we end up with the variables on one side and the constants on the other side. And then we solve. Or you end up with the specific variable you want on one side. Because you could end up with something like y equals 2x plus 1, except we have like 2y plus y. And if we want to isolate for y, well, what is y? Oh, we subtract y from both sides. So yeah, you isolate the variables you want on the one side, and then everything else is on the other side, and then you solve. So let's solve this equation. 12x minus 3 is equal to 4x plus 13. Well, that's 12x minus 4x equals 13 plus 3. Which is going to give us 8x equals 16. X is equal to 2. Notice that that's way easier to say than the, oh, let's subtract 4x from both sides and let's add 3 to both sides. Think of it as just rearranging. That's why the think of it as rearranging thing showed up. So let's solve these equations and check our solutions. 2x plus 1 is equal to x plus 5. Oh, hey, 2x minus x. So we move that over, or we subtracted x from both sides, equals 5 minus 1. So x is equal to 4. A plus 2 is equal to 4 plus 4a. Well, 4a minus a is equal to 2 minus 4. I, for one, am a fan of keeping the coefficients of the variable positive when it is reasonable to do so. Because, well, you can simplify and switch the sides in one move. So it's fine. It's not that much of a problem. A is equal to negative 2/3. So, y plus 22 is equal to 2y. Well, that means 2y minus y is equal to 22. Y is equal to 22. X equals 7x minus 3. Well, 3, move the 3 over and move the x over, equals 7x minus x. So 6x is equal to 3. X is equal to, you can go 3 over 6, or you can actually go straight to 1/2. Because everybody knows that 3 divided by 6 is 1/2. Now, for 2a minus 3 equals 4 plus 7a. 7a minus 2a is equal to negative 3 minus 4. And thus we have 5a is equal to negative 7. A is equal to negative 7 over 5. Or negative 1 2/5. Okay then. What about 7b minus 1 equals 14 plus 2b? Well, you got 7b minus 2b is equal to 14 plus 1. So 5b is equal to 15. B is therefore equal to 15 over 5, or 3. C plus 1 is equal to 4 plus 5c. As we can see, this is, you just isolate the variables on one side, well, the variable you want if you have multiple variables, and then you treat it like any other algebraic equation. So c plus 1 is equal to 4 plus 5c. got 1 minus 4 is equal to 5c minus c. So 4c is equal to negative 3. C is equal to negative 3 over 4. And here we got 4y minus y is equal to 3 plus 11. So 3y is equal to 14. Y is equal to 14 over 3, or 4 2/3. Yeah, it's like other algebra. You just rearrange as you need, except this time you're also rearranging terms that include variables, and then you divide. Well, after you finish adding or subtracting, you divide. If you have grouping symbols in your equations, you can remove the grouping symbols by using the distributive property. And then just multiply it out. Expand it. Yeah, that's one way you can do it. The other way is that you can use those grouping symbols to divide. How? Well, okay, one way is 2 times 6m is going to be 12m. 2 times negative 1 minus 2 is equal to 4m. So 12m minus 4m is equal to 2. So 8m is equal to 2. M is equal to 2 over 8, which is equal to 1/4. Okay, what's the other choice? The other choice is that you go 6m minus 1 is equal to 2m. In other words, you divide both sides by 2, because this side is 6m minus 1 times 2. Whereas the other side is, oh, it's divisible by 2? Wonderful, let's divide both sides by 2. And then we end up with this. So we also got rid of the bracket. And that's going to be 6m minus 2m is equal to 1. So 4m equals 1. M is equal to 1/4. Some equations have no solution, such as if you're trying to say that two parallel lines that don't overlap are equal. The solution set is a null or empty set, which we represent by an O or a 0 with a slash through it. Other equations have every number as a solution. This is called an identity. You could state this to be an identity by going x or whatever other variable is an element of the real numbers, so it's true for all real numbers, or you can just write identity, depending on convention. I for one am used to the x as an element of real numbers version. So let's solve each of these equations. 2 times x minus 1 is equal to 4 plus 2x. Well, you got 2x minus 2 is equal to 4 plus 2x. That's saying that negative 2 is equal to 4. So, no solution. This is not possible. Now, negative 2 times x minus 1 is equal to 2 minus 2x. What happens? Oh, you got negative 2x plus 2 is equal to 2 minus 2x. Everything cancels each other here. So 0 equals 0. Thus, x just needs to be an element of the real numbers for this equation to be true. At any value of x, this equation is true. Let's solve each of these equations and check your solutions. 12 times g minus 3 is equal to 30. You can go 12g minus 36. You can also go g minus 3 is equal to 30 over 12. Or you could even go part way. In other words, cancel the 12 down to a 2 and the 30 down to a 5. But let's just do it this way. Minus 36 equals to 30. 12g is equal to 66. G is equal to 66 over 12. So 11 over 2. Now, if your teachers really don't like improper fractions, sure, okay, this is 5.5. Now, to check our solution, we'd be like left side is equal to 12 times 11 over 2 minus 3 is equal to 12 times 5 over 2. And we'd cancel this, be 6. And then we end up with 6 times 5 equals 30. So left side is equal to right side. And QED. Now 6x plus 3 is equal to 21. You got 6x plus 18 is equal to 21. So you're dealing with 6x is equal to 3. X is therefore equal to 1/2. And for checking, we got left side is equal to 6 times 1/2 plus 3. So that's going to be 6 times 3.5, which is 3 by 7. So that's 21. Depending on teacher, you may have to state that right side equals 21. But left side equals right side, QED is how you end anyway. So you might have an extra line that says, oh, right side is also equal to 21. Or right side is also equal to whatever you found for your left side. If it's not, of course, you did something wrong. 2s plus 17 is equal to 5 times s plus 2. Well, you got 2s plus 17 is equal to 5s plus 10. So 5s minus 2s is equal to 17 minus 10. So we got 3s is equal to 7. S is equal to 7 over 3. Now we substitute in and we find that left side is equal to 2 times 7 over 3 plus 17. So that's 14 over 3 plus 17, which is, this is 15 over 3 minus 1/3. So 5 minus 1/3. So 4 2/3 plus 17, which is going to be 21 2/3. The right side was 5 times 7 over 3 plus 2. So 2 times 3 is 6. Then this is 2 1/3 plus 2 multiplied by 5. So we got 5 times 4 1/3. You could have gone from here straight to here if you liked, but well, whatever. So we end up with 20 5 over 3, which is equal to 21 2/3. So we have left side equals right side, QED. Now for 7y minus 1 is equal to 2 times y plus 3 minus 2. That's going to be 7y minus 1 equals 2y plus 2 times 3 is 6 minus 2. So 7y minus 2y is equal to 6 minus 2 is 4 plus 1. So 5y is equal to 5. Y equals 1. So the left side is equal to 7 times 1 minus 1, which is, of course, 6. And the right side is equal to, in case your teacher doesn't like you having a lot of questions written close together, you might want to invest in dashed lines as a sort of separator. Just saying. Right side is 2 times 1 plus 3 minus 2. Okay, so 2 times 4 minus 2. 8 minus 2, if you're particularly picky about following order of operations, instead of collapsing multiple steps together. So equals 6. And we get left side equals right side. QED. Here, 1 plus 2 times b plus 6 is equal to 5 times b minus 1. Well, that's 5b minus 5 is 1 plus 2b plus 2 times 6 is 12. So we got 5b minus 2b is equal to 13 plus 5. So that's 3b is equal to 18. B is equal to 6. Then we substitute in to find the left side and right side to check. That's 1 plus 2 times 6 plus 6. So that's 1 plus 2 times 12. If you want, you can go 1 plus 24, or you could just go to 25. Because this would be a simple multiplication and then an addition of 1, which many teachers might let you get away with not showing the individual steps. So 5 times 6 minus 1 is 5 times 5 for the right side, which is 25. So left side equals right side. Thus, quod erat demonstrandum. What is asked has been shown. 2x minus 5 is equal to 3x plus 3. 3 times x plus 3. Let's a bit more. So that's going to be 2x minus 5 is equal to 3x plus 9. So we're looking at 3x minus 2x is equal to negative 5 minus 9. So x is equal to negative 14. Now we sub in and we have left side is equal to 2 times negative 14. This is going to be negative 28 minus 5 equals negative 33. And the right side is 3 times x plus 3, so negative 14 plus 3 is equal to 3 times negative 11, so that's equal to negative 33. So because the left side equals the right side, what is asked has been shown. Inequalities. Well, they show that one side is greater than or less than, or greater than or equal to, or less than or equal to the other side. So there are many ways you can communicate these. Less than or equal to, no more than, or at most. they mean the same thing. At least, greater than or equal to, or no less than, they mean the same thing. Is greater than, is more than, or exceeds, they mean the same thing, which is strictly greater than something else. And is less than, is fewer than. Sometimes you see these as is strictly less than, is strictly greater than. Now let's write an inequality for each sentence. Less than 150 students attended the last dance. If we need a let statement, let variables be x, then we put 1. If we didn't need a let statement, well, you could have written s is less than 150, because s for students, yeah. So this would be x is less than 150 because we said let the variables be x. Less than 150 students attended the last dance. At the store, the camera cost at least as much as the mail order price of $299. Well, at least as much means it could be equal. So it's greater than or equal to $299. That would be the price of the camera. So you can graph an inequality on a number line to help visualize the values that make the inequality true. Graph each inequality on a number line. There's actually two ways, two conventions for graphing inequalities. The open circle for not including this point and closed circle for including this point, they stay the same. But one convention is that you draw your line along the actual number line, like you draw your arrow that indicates which way the inequality goes along the number line. This is for some reason used in some places in North America, but in my opinion it is gravely inferior to the choice of illustrating the inequality above or below the number line. Either way, you should label your inequalities. X is less than or equal to 4. Depending on convention, you may or may not need an arrow as long as you surpass the last tick mark or surpass the end of your line in either direction for the number line. So, find the range of values that fulfills both. Why do I prefer this above or below approach? It's because it enables you to show both easily. So the overlap is this part. So we're looking at x is greater than 3, strictly greater, and x is less than or equal to 4. So the range of values that fulfill both are x is less than or equal to 4 and strictly greater than 3. If they went up and diverged without overlapping, you would say no range of values satisfies both, or just say null set with the O with the slash through it. Let's write an inequality for each sentence. Well, let unknowns be n. A number decreased by 25 is no more than 65. So n minus 25 is not more than 65. It could be equal, so it's smaller than or equal to 65. Yes, when you do it in handwriting, this symbol is perfectly fine. You also see in some places this version. Just know that they both exist. The flat bottom line or the parallel bottom line? At least 80 runners showed up for the charity race. Well, the number of people who showed up was at least, so greater than or equal to, 80. Graph each inequality on a number line. X is strictly greater than 3. Didn't we just do this? Okay, let's show the other way now. So this is X is strictly greater than 3. Notice the open circle. It means 3 is not included. A is less than or equal to negative 1. Well, you have a closed circle here, so you have it filled in. And you label this. A is less than or equal to negative 1. Closed circle means it includes that point, so less than or equal to. B is less than negative 2. You have an open circle. And B is less than negative 2. I'm used to the convention where you don't necessarily put an arrow on your inequality as long as you lead it off the number line. Like it surpasses the end of the number line by a bit. If your teachers require that you put an arrow on it, put an arrow on it. Yeah, that's not exactly that complicated, huh? So, like this. And of course, you label your inequalities. C is less than or equal to negative 5. Let's say we have a relationship where 5 is bigger than x. Okay, then if we add 2 to both sides, is 7 still bigger than x plus 2? Yeah, it is. So the addition and subtraction properties of inequalities are the same as for equations. When you add or subtract a number from each side, the inequality remains true. For example, solve 12 plus y is greater than 20. Well, y is greater than 20 minus 12. So y is greater than 8. Okay, then check your solution. Left side is equal to 12 plus y, which is greater than 12 plus 8, because y is greater than 8. That means left side is greater than 20. Right side equals 20. Thus, left side is greater than right side, as we wanted. So QED. Of course, you have to make sure that the left side, right side numbers actually match up, because if you got left side is greater than 21, right side equals 20, and you say that left side must be greater than right side, yes, but no. So you got something wrong. Exercises. Solve in each inequality. 11 is less than 8 plus b. That means b is greater than 11 minus 8. Now what happens if we want to switch the direction? So switch the sides. Oh, b is still greater than 11 minus 8, which is 3. But you notice that the direction of the arrow has changed because we flipped the sides. 5 is greater than 3. Well, what happens if we flip the sides? Oh, it has to be 3 is smaller than 5. So, what would happen if we decided to check this? Well, left side equals 11. Okay. Right side is equal to 8 plus b, which is greater than 8 plus 3, because b is greater than 3 is what we found. Therefore, right side is greater than 11. Right side is greater than left side, which is what we have here, sus QED. That is how you prove an inequality after you find a solution and need to check it. T minus 3 is greater than negative 4. Well, T is greater than negative 4 plus 3. So it's greater than negative 1. Okay, then if we wanted to check this, we would have left side is equal to T minus 3, which is greater than negative 1 minus 3. So greater than the substitution or less than the substitution as relevant, or greater than or equal to, or less than or equal to as relevant. So you end up with left side is greater than negative 4. Right side equals negative 4. Left side is greater than right side. Oh, hey, we've just shown that this answer is correct. B minus 1/4 is less than 2 1/4. Well, B is less than 2 1/4 plus 1/4. So it's less than 2 1/2. So, if we were to check this, we'd get left side equals B minus 1/4 is less than 2 1/2 minus 1/4. Left side is less than 2 1/4. Right side equals 2 1/4. Left side is less than right side. Therefore, QED. So negative 2 plus Z is less than 5. Well, Z is less than 5 plus 2. So less than 7. Think about it. A value that's less than 7 minus 2 is going to be less than 7 minus 2, or 5. Now M, if we isolate M here, we'd get M is greater than 6 plus 6, so M is greater than 12. Checking this, we get right side equals M minus 6, which is greater than 12 minus 6 is greater than 6. Left side equals 6, right side greater than left side, QED. 4 1/2 plus B is greater than 7. B is greater than 7 minus 4 1/2. B is therefore greater than 2 1/2. Okay, then, if we check this, left side is equal to 4 1/2 plus B, which is going to be greater than 4 1/2 plus 2 1/2. Therefore, left side is greater than 7. And then, right side equals 7, so left side greater than right side. Oh, QED. What's been asked has been shown. Everything matches up. Use the multiplication and division properties of inequalities to solve them. When you multiply or divide each side by a positive number, the inequality remains true. The direction of the inequality does not change. Why is this? Well, let's say we have a number line. Okay, so 0 is here, and you got A and B. Well, what happens if you have, say, 3A and 3B? Well, we got B is greater than A, and 3B is greater than 3A, right? Hey guys, what happens if we decide to flip this over, like negative 2A and, okay, that's negative 2B, roughly around here-ish. Okay, then, we would find that negative 2A is greater than negative 2B. Or, if we wanted to write it with B on the left side, like before, we have negative 2b is smaller than negative 2a. When we multiply or divide by a negative number, the inequality changes directions because you're flipping it over the 0 on your number line. Therefore, what used to be smaller, i.e. less positive, is now less negative. Or what used to be less negative, i.e. bigger, is now less positive, i.e. smaller. But if you scale it without using a negative sign, all you're doing is, oh, what used to be big got bigger. What used to be small, well, it got bigger, but not as much. So let's solve 8x is greater than or equal to 72. Check your solution. X is greater than or equal to 72 divided by 8. So x is greater than or equal to 9. Check your solution. Left side is equal to 8x, which is greater than or equal to 8 times 9. So left side is greater than or equal to 72. Now the right side equals 72. Left side is greater than or equal to right side. Sus quod erat demonstrandum. What is asked has been shown. For an inequality to remain true when you multiply or divide the negative, you have to change the direction of the inequality symbol, such as with this example. Y is going to be greater than 2 times negative 3. It's greater than negative 6. Okay, let's check this. How does it work? Left side is equal to y over negative 3, which is, well, y is negative 6. So y is a number that is bigger than negative 6. What's the dividing going to give you? Oh, negative 6 divided by negative 3 equals 2. Okay, but if it's bigger than negative 6, then you're going to end up getting, say, negative 3 divided by negative 3, which is going to just be 1. So this is going to be less than negative 6 divided by negative 3. Because your y is greater than a negative amount. That means when you're dividing by a negative 3, the direction of the inequality changes, because instead of negative 6 divided by negative 3, which gives you 2, you could have something like negative 5 divided by negative 3, which is going to be less than 2. So less than this. So left side is less than 2. Right side equals 2. So left side is less than right side. Sus quod erat demonstrandum. So graph the solution. Y is greater than negative 6. Y is greater than negative 6. So, exercises. Solve each inequality and check your solution. H over negative 2 is greater than or equal to 5. So, H is less than or equal to 5 times negative 2. So, we got negative 10, and the left side, we got a number that's less than or equal to negative 10 being divided by negative 2. Well, because dividing by negative 2 gives us a direction flip, it is now greater than or equal to negative 10 over negative 2. Now we go from h is less than or equal to negative 10 to h divided by negative 2 greater than or equal to negative 10 over negative 2. If you think about it, this makes sense because you could have, say, negative 12. And then you could end up with, oh, dividing by negative 2, you get 6 instead of 5. Oh, that's greater than, right? So if you're ever in doubt of what you just did, you can try some numbers. Well, this leaves us with left side greater than or equal to 5. Which means, oh hey, right side equals 5. Left side is greater than or equal to right side. Thus, what is asked has been shown. QED. Negative 20t is less than or equal to 80. T is greater than or equal to 80 over negative 20. So it's greater than or equal to negative 4. Now the left side is equal to negative 20t. We started at t is greater than or equal to negative 4. Then we multiply both sides by negative 20, and what happens? Oh, it's got to be less than or equal to now negative 20 times negative 4. So that's going to be less than or equal to 80 for the left side. Right side equals 80. Thus, left side is less than or equal to right side. QED. Basically, you just work the problem backwards. And if you end up where you started, then congratulations, your final answer was correct. If you didn't end up where you started, you made a mistake somewhere. Okay, so negative 6 is less than c over negative 2.5. So c is less than negative 6 times negative 2.5. Right, so c is less than 15. Now, right side is equal to c over negative 2.5, which is going to be, well, we started off with c is less than 15. And what happens if we divide both by negative 2.5? We end up with c over negative 2.5 greater than 15 over negative 2.5. So it's greater than negative 6. Left side is equal to negative 6. So left side is less than right side. Thus, quod erat demonstrandum. 4 over y is greater than 0.5. Well, we multiply by y on both sides. And we get 0.5y is less than 4. So y is less than 4 over 0.5. 0.5. Y is less than 8. Does this work? Well, we have a bit of an issue here, guys. 4 over y is greater than 0.5 works between 0 and 8. Hold on. What about y is less than 0? Well, it doesn't work when y is less than, or equal to for that matter, 0. For y equals 0, you get undefined. And if y is less than 0, well, 4 divided by a negative number is going to be a negative number, which will be smaller than 0.5. So the actual answer is y is less than 8 and greater than 0. Yeah. When you check the answer, you would find that left side is equal to 4 over y, which is, well, y is less than 8. So if you're dividing by a number that's less than something, you end up with a result that is greater than 4 over 8. Because you're dividing by something less than 8. If y positive. Or you could just write if y is greater than 0. So left side is greater than 0.5. Right side is equal to 0.5. So left side is greater than right side. QED. If y is greater than 0. So the answer is y is between 0 and 8. If you get a function that is, say, 4 over x or 1 over x, it has a very distinct shape. Looks kind of like this. So both of these go up to infinity, and there is no value when x is equal to 0. 4 over y, well, all you're doing is changing the axis labels a bit. And greater than 0.5, oh, hey, that just means you're finding at what range does this occur. Yeah, so visualizing the functions that you're dealing with or the relations that you're dealing with is very useful. Be very careful when you have your variable in the denominator, because you're probably looking at a rational function which has a very distinct shape. Well, we can discuss that in greater detail later, like in later grades. If your inequality needs multiple steps to solve, you can do it just like you would a multi-step equation. You do the operations in reverse order, or undo them, and remember to reverse the inequality symbol when you're multiplying or dividing each side by a negative number. So, what happens if we add 2x here to both sides? Well, we end up with, also subtract 24 from both sides, we end up with 2x plus 2x. So that's going to be 4x is greater than negative 12. X is greater than negative 12 over 4. So x is greater than negative 3. Negative 3 greater than negative 3. Now, if the inequality contains parentheses, use the distributive property to begin simplifying the inequality. Or you can divide the number that the parenthesis is multiplied by. So you can cancel a bit, as I showed earlier. Exercises. Solve each inequality and check your solution. C plus 4 is less than or equal to 4c minus 2. Well, 4c minus c is greater than or equal to 4 plus 2. So 3c is greater than or equal to 6. C is therefore greater than or equal to 6 divided by 3, so 2. Now checking our solution means left side is equal to c plus 4, which is greater than or equal to 2 plus 4. So left side is greater than or equal to 6. Okay, what about the right side? Right side is equal to 4c minus 2, which, because c is greater than or equal to 2, is greater than or equal to 4 times 2 minus 2, which is, again, 6. Oh dear, we have a problem. How can we prove that right side? How to show that left side is smaller than or equal to the right side? Or right side is greater than or equal to left side? Look at the growth rate. Left side, for every 1 growth in C, left side grows by 1. Right side grows by 4. Has a greater coefficient on C. Which means that as C grows, like as you move C away from equals 2 into greater territory, the right side will grow bigger numerically at 4 times the rate of the left side. Therefore, the right side would then, if C is not equal to 2 but instead greater, the right side would be greater than the left side. How else could you prove this? You could also test C equals 3, which is a number that's greater than or equal to 2, to show that, oh, right side is greater than left side on this range. Because we can see that these expressions, they're not the same, which means that if you find that when C is greater than or equal to 2, right side should be bigger than left side, then just prove that at some point where C is greater than 2, this is indeed the case. That also works as a check by North American standards. It's less theoretical and less universal than the right side has a greater coefficient version. And what else? Also, C is positive. So C being positive is kind of important for the greater coefficient to work. C is greater than 0. Yeah, okay, so 12 minus 2n greater than or equal to 6. That's going to give us negative 2n is greater than or equal to 6 minus 12. So n is going to be less than or equal to negative 6 over, so n is less than or equal to 3. So left side is equal to 12 minus 2n, which is, because n is less than or equal to 3, we got to change the direction when it's multiplied by negative 2. So it's greater than or equal to 12 minus 2 times 3. So because we're subtracting less than or equal to 3, therefore the result is going to be bigger than or equal to just subtracting something, the appropriate multiple of 3. So it's going to be greater than or equal to 12 minus 6. So it's greater than or equal to 6. And right side is equal to 6. So left side is greater than or equal to right side. And QED. Okay then. Three is 3 times 2d plus 1 is less than negative 15. You know what? I'm just going to go with this approach. 2d plus 1 is less than negative 15 divided by 3, or negative 5. Okay, 2d is less than negative 6, because minus 1 from both sides. D is less than negative 3. Okay, we can prove this by substituting a value within this range, such as d equals negative 4. Like, that is actually considered a valid proof by North American standards, but a more universal proof is left side equals 3 times 2d plus 1, and we know that's going to end up being a positive multiple of d. So 6 times d. Now, if d is less than negative 3, then 6d must be more negative. So it's smaller than 3 times 2 times negative 3 plus 1. So it's smaller than 3 times negative 6 plus 1. Left side is therefore smaller than 3 times negative 5, which is smaller than negative 15. Left side. And right side equals negative 15. So you got left side is smaller than right side, which is what we're supposed to find, thus QED. This has been proved. B over 3 plus 9 is greater than 8. Well, B over 3 is therefore greater than 9 subtracted from both sides. That's going to end up with 8 minus 9, or negative 1. So B is greater than negative 1 times 3, or negative 3. Okay, then, what's the left side look like? The left side is equal to B over 3 plus 9, which is bigger than, because B is bigger than negative 3, and we have a positive number that's multiplying it. And by multiplying, I mean B times 1/3. Negative 3 over 3 plus 9. So it's greater than negative 1 plus 9. Left side is greater than 8. Right side is equal to 8. So left side is greater than right side, which is what we're supposed to find. Thus, what is asked has been shown. QED. All right. So, inequalities are basically like equations, except when you multiply or divide by a negative number, you need to change the direction of the sign, because you can think of it as flipping the relationship of two numbers over on the number line. What used to be closer to 0 is still closer to 0. But if it was less negative, now it's less positive. If it was less positive, now it's less negative. So the relationship between the sides of the inequality changes direction. Well, that's it for this chapter. See you next chapter.